Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss all the four problems asked in today's LeetCode Weekly Contest 469. So let's start with the first problem. It says you are given a positive integer n, and a positive integer is a base 10 component if it is a product of a single digit from 1 to 9 and a non-negative power of 10, right? For example, 537. These are all our base 10 components, right? And so what we have to do, we have to express the given integer n as a sum of only base 10 components, right? And using as minimum as possible, and we have to return an array consist of base 10 components in descending order, right? So for example, 537, your answer is 500 plus 30 plus 7. Now for 102, it is 100 plus 2, right? And for 6 is the only possibility, right? So yeah, this is an easy problem. Let's see how we can approach it. Let's say in the second problem you are given n as, let's say, 5, 0, 1 and 2, right? And we have to divide this given integer into base 10 components, right? So we know that the answer for this is going to be 5, the 5000 plus 10 plus 2, right? So what we can do, so it's an implementation problem. We know that to implement this approach, what we can do, we can create a variable called multiply. Initially it would be 1, right? So it would start from here, and each time it would be multiply by 10, right? Because the index for this is 10 to the power 0, this is 10 to the power 1, this is 10 to the power 2, this is 10 to the power 3, right? So we will start from here. We will get the last digit. Let's say that digit is digit, right? So your current base 10 component is going to be digit into 10 to the power I, right? So this 10 to the power I is essentially this multiplication, your current multiply, right? So it start from 10 to the power 0 to 10 to the power 1, then 2 and then 3 and so on, right? So this is my current base 10 component, and this just insert that into your vector, right? Because we have to return the vector. So yeah, this is the implementation problem. Let's see how we can write code for it. Here is the code. This is my integer n, this is my answer, this is my multiplication, that would be initially 1. Now I'm going through all the digits from given integer n. So this is my last digit. If that digit is positive, just insert that digit into multiply. So this multiply is essentially 10 to the power I, right? And then push that into the answer vector, then multiply equals to 10, because each time it would be from 10 to the power 0 to 10 to the power 1, 10 to the power 2 and so on. Now divide the n, right? So one thing, in the problem statement you have to return the vector in the descending order. So since so like currently the answer would consist of answers like the sum from lower to maximum, so just reverse that and return the answer, right? So yeah, this is the code of first problem. Let's see the second problem. In the second problem, you are given an integer array nums. We have to split the array into exactly two subarrays, left and right, such that left is strictly increasing and right is strictly decreasing, right? And we have to return the minimum possible absolute difference possible between the sum of these left and right subarrays. And if there is no valid split, just return -1, right? And a subarray, we know what is subarray, right? So yeah, for example, here in this test case 1 2 4 3, so there are three ways to split it. One subarray consists of 1 and rest is 2 4 and 3. Second could be 1 2 and then 3 4. The third could be 1 2 4 and the second subarray is 3, right? So just remember, this subarray should be non-empty, right? So among all these three partition, the minimum difference possible is 4, right? So it could be from split 1 and split 2 as well, right? So yeah, this is a implementation problem. So let's see how we can approach it. In the second problem, let's say this is my given array, right? and so index from 0 to n minus 1. So what we will do, we will create two vectors. One is increasing vector and one is decreasing vector. So increasing vector of I would be 1 if the subarray from this 0 to I is strictly increasing, right? Otherwise it would be 0. And similarly decreasing of I would be 1 only if the subarray from index I till n minus 1 is strictly decreasing, right? If 0, right? So once you create these two vectors, so the job is easy. We will go through each index. We will check if both left and right subarray are increasing and decreasing respectively. So we will check if increasing of I equals to 1 and decreasing of I plus 1 equals to 1, right? If one of the subarray is like the left subarray is strictly increasing and the right subarray is strictly decreasing, your answer is going to be minimum of answer comma just update the answer. So let's say this is my left sum, left, right? So the right sum is going to be total sum, right? Let's say the sum is the sum of all the numbers minus left, right? Minus left. So what is the difference? Difference is mod of sum minus left, right sum minus left sum, right? So it is nothing but sum minus 2 times left, right? Let's say this is my diff. So just update your answer. Your answer is going to be minimum of answer comma diff, right? Yeah, that's it. And at the end return the minimum answer, right? So yeah, this is the approach. Let's see how we can write code for it. This is the code of second problem. So this is my nums array, right? So I created two vectors. One is increasing and one is decreasing, right? So I build this increasing and decreasing array. So initially increasing of 0 is equal to 1, right? Because if you have just one number, it is anyway strictly increasing. Now for other indexes from index 1 to n, your increasing index of I equals to your previous and your current number should be greater than the previous number, right? Similarly for decreasing, your decreasing of n minus 1 is going to be 1 initially. Now from index n minus 2 to 0, your decreasing of I equals to decreasing of I plus 1 and your current number should be greater than the next number, right? So nums of I is greater than nums of I plus 1. So once you build this increasing and decreasing vector, the job is easy. So let's say this is my total sum, like the sum of all the numbers. Now this is my answer. So initially answer is, let's say 10 to the power 12 I have taken. This is my left sum. Now what I'm doing, I'm going through each of the index. So this is my left sum, I mean the sum till from index 0 to I. Now I just check if my like the subarray from 0 to I is strictly increasing and subarray from I plus 1 to n minus 1 is strictly decreasing. If both are true, just update the answer. Your answer is going to be minimum of answer comma absolute value of sum minus 2 into left. Please check out the explanation part where I have explained how this sum minus 2 into left comes, right? So this is my left sum. The right sum is going to be total sum minus left. So the difference is sum minus 2 into left. Now just check if the answer is infinity. So if your answer is infinity means there is no way to split the array into exactly two subarrays, right? So your answer is going to be minus 1 and at the end return the answer. So yeah, this is the code of second problem. Now let's look at the third problem. This is the third problem asked in today's contest. So it says you are given three integers n, l and r. Now a zigzag array of length n is defined as each element of this zigzag array is from the range L to R. Now no two adjacent elements are equal, okay, and no three consecutive elements are either strictly increasing or strictly decreasing. Alright, and we have to return the total number of zigzag array possible. Now the answer could be very large. You have to return it modulo 10 to the power 9 plus 7, right? So yeah, this is a good problem and a DP problem. Let's see how we can approach it. So in the problem statement, we are given n, l and r, right? So all the numbers in the zigzag array should be from the range L to R, right? I would like to do one thing. I would like to change this L to R from 1 to m, 1 to let's say the total m is r minus l plus 1, right? So I would like to change this l to r from 1 to m. The answer is still going to be the same. The number of ways is not going to change if you change the range, right? So range is just a number uh, which you want, like which you can pick from the given range, right? So I just change the range from 1 to m, where m is r minus l plus 1, to make the problem, I mean, like easy to code, right? So now your range become n. Now, I mean, your problem statement essentially becomes n, 1 and m. So this is, so the numbers should be from 1 to m, where m is r minus l plus 1, right? So this was one point. Now see, whenever in a problem you have to find some mean, max, number of ways, always think of it, I mean, like always try to think it, if it like if this problem could be solved using dynamic programming. So here we can, right? So let's see how we can approach it. So we know that the two number cannot be same, right? So let's say this is my current number, for example 5. I know that the next number cannot be 5, because the problem statement strictly says that the two consecutive numbers cannot be same. It means that this number could be either, let's say 6, I mean increasing number, or it could be decreasing number, so let's say 4, right? And in the problem statement it also says that none of the three consecutive integers should be strictly increasing and strictly decreasing. What it means, let's consider the first case when your next number is greater number, right? We know that this is an if strictly increasing part, right? 5 is less than 6, right? What are the possibilities at the third place? It must be more than 5, because if it is less than 5, because I know that I cannot keep 5 here, because then it would violate the first condition where two numbers cannot be exactly same. So I cannot keep 4 here, because then it would be a 3 consecutive number of strictly increasing. Means that this number has to be increasing, right? So it has to be 7 or something else, like something more than 5. Similarly here, I know that if my next number is smaller, means this is in a strictly decreasing part. It means that this number cannot be more than 5, it has to be less than 5, right? So let's say this is 4. So see, so your total see, your zigzag array would look like increasing, decreasing, increasing, decreasing, increasing, decreasing, increasing, decreasing, and so on, right? So it may start with first increasing, or it may start with decreasing, increasing, decreasing, increasing, decreasing, increasing, right? So this is the structure of your zigzag array, right? So yeah, like if you understand this part, I think you are very close to solve this problem. Now let's see how we can apply DP for it. So let's say I am at index I, right? I want to keep some number at this index, right, from the range 1 to m. Now what is important so far? What information which you like, let's say if someone give you that information, you can solve that problem. So that information is, let's say I want to keep the value here, let's say the value which I want to keep here is value, right? What information do you need? I need at the previous index, I minus 1 index, give me, I know that my array is going to be zigzag array, right? So there are two possibilities, either the previous number is more than me, or the previous number is smaller than me, right? So let's consider the first case when your previous number is smaller than me, right? So let's say this number is from 0 to val minus 1, sorry, 0 to val minus 1, right? The first case when your previous number is smaller, in that situation, what information do you need? Give me how many number of ways to form the zigzag array at index I minus 1, right, such that the previous value is smaller than me, and I know that if the previous number is smaller than me, this is strictly increasing, right? It means that this number has to be, I mean the previous of previous number, this number has to be more than me, right? Because this is my current zigzag form, so it has to be decreasing, right? So it means that I need the information at previous index. So dp of I minus 1, so let's say this is my value u, let's say this is value u, and u is from 0 to val minus 1, I mean is smaller than val. U, let's say I have chosen u. Now I want the third information. So let's say this is my dp. So let's say this is a 3D dp of n, m, and 2. So 0 is for increasing and 1 means for decreasing, let's say. Now I want dp of I minus 1, u, and 1, because I want this to be a decreasing. Then only I can increase it from here. So I need that information, that's it. In the second possibilities, let's say this is my current value and the previous number is greater than me, right? So this is from, let's say, val plus 1 to m. So I know that this is anyway decreasing, so it has to be increasing. So what information do you need? I need the information of dp of I minus 1, u, and 0. I want increasing here. That's it. That's all. That's all about this problem. So this is how I applied dp here. So there are three information. So the state of the dp is 3, because I need three info. First is the previous index. The second is what value which I want to keep at the previous index. Now the third information is either it is strictly increasing or strictly decreasing. That's why the state of dp is 3, right? So yeah, that's all about the problem. So the complexity for this is order of n, and because I'm iterating through all the indexes from 0 to n minus 1, m, because I have to iterate through all the possibilities of current value, so this value could be from 1 to m. Now again m, because I have to iterate through all the possible values at the previous index, and it could be from 1 to m. So the complexity is order of n into m, and if you notice the n and m could be 10 to the power 3, so it won't be accepted. The idea is correct. If you write a code for it, I will show you the code. I have written both the code. One is using this approach, order of n into m square, but that was giving me TLE, so I have to optimize it. I'll show you the optimized code also, but how I did the optimization. So what I did, if you remember here, if you fix the current value, the previous value, so in the first case, the previous value is from 0 to m so 0 to l minus 1, right? Now for this, for the second case, let's say this is my current value. The previous value is from value plus 1 to m, right? And I know that. So what information do you need? So here what I'm doing here, so your answer is going to be answer plus equals to this value, right? Similarly, plus equals to this value. So if somehow, and one thing, you don't need, so you only need the previous information, right? The previous index I minus 1 information. See, to update the dp of I, you are using dp of I minus 1, not dp of I minus 2 or any random dp of I minus k. So you are using dp of I minus 1. So what we can do, we can create two vectors, right? So one is let's say vector a, and one is vector b. So vector a can store let's say for this part I use vector a. Now for this I use vector b, and what it will essentially store, it will store let's say this is my vector of a. Vector of a of I will store vector of the sum from 0 to I of this 1, and similarly here vector of b would store from I plus 1 till m of 0, right? So what I'll do here, I'll build this current dp, then I'll store these two information, vector a and vector b, to store the sum from 0 to value minus 1, and the second vector could store the sum from value plus 1 to m of 0. 0 means decreasing and 1 means increasing. So I'll use this optimization. So but for you, I would highly recommend to solve this version of the problem, so where there was no optimization, though the complexity was n into m, but you can write code for it. So if you write a code, you would see what optimization which you can do, right? So yeah, let's see how you can write code for it. So I'll show you both the code. One is non-optimized and one is optimized. So here is the code. This is a non-optimized code. So the complexity for this is order of n into m square. So yeah, it won't be accepted, but this is very important to write the final optimized code, right? So here, this is my mod, this is my DP. So please check out the explanation part I have explained there. So we need 3D DP. So DP of ij0 means the number of zigzag array such that the value at current index I is j, right? Then the current value at index I is j, and 0 means your current number is greater than the previous number, right? So this is an increasing value. Now similarly, DP of I is j1, it means the number of zigzag arrays possible such that the value at the current index is j, and this current number is smaller than the previous number, right? So yeah, this is the definition. Now as I mentioned, I have changed this range from L to R to 1 to M, right? Now so I'm just making DP of ijk is equals to 0, right? So now what I'm doing here, now see we have to build the DP from index 1 to M, sorry, 1 to N, right? So index is from 1 to N. Now for 2, so 2 means the second number, right? So I'm creating so I'm building the base case. So for two numbers, let's say at index 2, I want to keep this value and I want to make it 0. 0 means increasing, right? So I want to make my current number is greater than previous number. So the total number of ways would be, so see, if my current value, so the value at current index 2 is value. So what are the possibilities of the previous number? It is either from like, so it could be either 1, 2, 3 up to value minus 1. So the total number of ways is val minus 1, because if my current value is value and I want to make it greater than the previous number, so the previous number has to be smaller than this val. And what are the total number of options? 1 to val minus 1. So the total possibility is val minus 1. Similarly here, dp of 2 val 1 is equal to m minus val, because now I have to make is decreasing, right? So the current number has to be less than the previous number. So the options are from val plus 1, val plus 2, val plus 3 up to maximum m. So the total possibilities are m minus val. So this is my base case. Now for index 3 to n, I'm going through all the possibilities of value. So the possible values could be from 1 to m. Now there are two cases. The first case, if when your previous number is smaller than the current number, right? So from value is equal to 1, value is less than value. If the previous number is smaller than 1, now I'm updating the DP of I val 0 plus equals to I minus 1 u. So this is your value, and 1, because 0 means I am increasing, like, so I'm greater than you. But since we also have to take care that none of the three consecutive integers are strictly increasing and decreasing. If I am more than you have to be smaller than your previous. That's why it is 1 here. 1 means for smaller and 0 is for greater. So if I am more than you have to be smaller than your previous. So that's why it is dp of I minus 1 u1, and same modulo equals to mod. Now the second case, when previous number is more than me, right? So in that case, your since I am more than you, right? Not I am. So if the previous number is more than me, means I am is smaller than you. If I am is smaller than you and none of the three consecutive numbers should be strictly decreasing, you have to be more than your previous. That's why here dp of I val 1 equals to dp of I minus 1 u and 0, because if I am is smaller than you have to be more than your previous, and same modulo equals to mod, and that's it. Your answer is 0. Now your answer is going to be dp of n value and 0 and 1. So the last number, and the last number could be either strictly increasing and decreasing. So yeah, that's it, and return your answer. So yeah, this is the optimized, this is a non-optimized code, but this is an like correct code. If you have the constraint is smaller, it would be accepted, but given the constraint, it won't be accepted because the complexity here is order of n into m square, right? So please check out the explanation part. I have explained there how we can optimize it. So if you notice here, what we are doing essentially, we just, so if let's say if someone, so let's say if someone give you that information, so let's say there is a genie that will give you what at the previous index I minus 1, I'll give you uh, value minus 1. I mean, so see here we need a sum from 1 2 3 up till value minus 1. So what essentially you are doing here, this is nothing but dp of I minus 1 1 1 plus dp of I minus 1 2 1 and plus so on, right? So essentially this means I need dp of I minus 1, this is from 1 till value minus 1, and this is 1, and similarly here. So this is nothing but dp of I minus 1, the sum of from numbers value plus 1 till m and 0. So if someone give you that information, you can just easily update your current dp of I val 0. Like you don't, so see in this loop what you are doing, you are just taking the sum of these many numbers. So what we can do, we can do something smart. We will store this information, we will store this into some array, let's say left array and right array or something, and then we can make use of it. We will use it and we will update it again. So in that situation you can avoid this extra loop here, right? And once you avoid this extra loop, the complexity become order of n into m, and that is accepted. So yeah, this is the optimized code. Let me uncomment it, right? So let me first run the code with with this non-optimized code. See, all the cases are accepted. So yeah, let me uncomment this, right? And let me comment the previous code. So yeah, this part is exactly same, this part is also same, right? So here for the optimization I used two vectors, one is previous left and one is previous right? So previous means the previous index, left means the name given left is because I want the left number. So let's say my current number is value, the previous number is from 1 to val minus 1, right? I need that information. And for 1 to val minus 1, I know that my current number is val, the previous number is 1 from val minus 1, means that I am more than you. So what I want you to be smaller than your previous. So, and we know that for a smaller we need 1, like the index 1 is for smaller and 0 is for increasing. That's why the previous left of val is equal to previous left of val minus 1 plus dp of 2 comma dp of 2 val and 1, right? And similarly for right. So right means I want previous number to be more than me. So let's say my current number is value, I want my previous number to be from val plus 1 to m, and since I am smaller than you, I want you to be more than your previous. That's why I use index 0 here. Now that's it. And for index 3 to m 3 to n, this is my current left and current right, and at the end of this building just update your previous left and previous right. So previous is equal to current, right? So I'll come to this part now here what I'm doing here. So if you remember in the non-optimized code, for the value 1 to m, you are iterating one extra, so you are having one extra loop to get the sum, right? But here what we will do here, we will just directly update the value from the stored information. So just give me previous left of val minus 1. So this essentially is exactly same as this value. right? So this is nothing but yeah, here this is nothing but this value, and similarly here, so this is nothing but this value, right? So yeah, so this way you have optimized the code. You don't need to have an extra loop for that. Now once you update it, just update your current left and current right, because we have to build it, right? We have to build it for the current index so that the next index can make use of this information. So yeah, we know that the current value is going to be for index 1 and your current right is going to be for index 0. That's it. And this is exactly same as the previous code, and return your answer. So now the complexity is order of n into m, right? So I'll highly recommend to solve this problem the way which I have explained, because I have seen 100 of times this optimization, that you have to optimize some code from n cube to n square, and even in multiple interviews also, right? Let's say you come up with a problem that is of order of n cube or something extra, and you have to optimize it. So just think about what information which you can store, so that you can avoid one extra loop, because if you avoid one extra loop, your complexity drastically decrease to some one less polynomial, right? So from n cube to n square, n to the power 4, let's say, to n cube, and so on, right? So yeah, this is all about the third problem. Now let's look at the fourth problem. This fourth problem and the previous third problem is exactly the same. The difference is only come from the constraint. So in the third problem, the value of n was up to 10 to the power 3, but here it could be 10 to the power 9. And L and R was up to 10 to the power 3 in the previous problem. Now it is up to 75. So this is decreased, but this is drastically increased from 10 to the power 3 to 10 to the power 9, right? So it means that 10 to the power 9 means that we cannot use any kind of array for the index, because we cannot have an array of up to 10 to the power 9, right? So yeah, so this problem is essentially a matrix exponentiation problem. So I'm still writing the code, but yeah, I can tell you the algorithm. The algorithm to solve this problem is matrix exponentiation. So I would highly recommend to learn this algorithm. This is called matrix exponentiation. So learn it and then try to solve this problem, right? So yeah, if you need the solution of four problem, I can make a separate video for that. So right, yeah, so if you need, please write a comment for that. I'll make a video explicitly for the fourth problem using matrix exponentiation, right? So yeah, this is all about today's contest. If you find the video helpful, please like, share, and subscribe to my channel. Thanks for watching. Have a nice day.